Hello everyone, welcome to this video. Continuing the verifying identities, I'm just doing a bunch of examples. And as you know, this is my toolbox. This is all that I get to work with and not have to prove. Everything else is algebraic. And again, this is what a lot of books will suggest, so you could pause that and read. So we'll start with our first example for this video. And we've been getting progressively more difficult. So now here, as I look, definitely this side, the left side, is more complex, so I want to work with that. And I also like that it's already in terms of sine and cosine. So I really am doing these cold. Well, I'm going to have to get a common denominator, so let's see if that gets us anywhere. So the common denominator would be sine alpha and then times quantity 1 plus cosine alpha. So let's just start there, see if anything falls out. So here I'm going to multiply by 1, but I'm going to do it in this form, 1 plus cosine alpha over 1 plus cosine alpha. Right? So here, this is an expression. I'm multiplying by 1, so I'm not changing the value, just changing the form. Same thing over here, but I multiply by sine alpha over sine alpha. And so what I'm going to get, oops, sorry about the shaking. Ooh, that must have been bad. Oops, sorry, let me stabilize that. All right, so now essentially this fraction and this fraction will both have the same denominator, which will be sine alpha times 1 plus cosine alpha. Okay, and then we'll have that equal here. But over here, I'm going to have basically 1 plus cosine alpha, the whole quantity squared, which is going to give me 1 plus 2 cosine alpha plus cosine squared alpha. And then over here, I'll have plus sine squared alpha. Okay. Now, what I can see here is that already I've got some recognition here, right? Cosine squared alpha plus sine squared alpha, that's just 1. Right? So I could say 1 plus 2 cosine alpha plus 1 for all this, all over sine alpha times 1 plus cosine alpha. Okay. Now, 1 plus 1 is 2, so let me just say I'm going to have 2 plus 2 cosine alpha all over sine alpha times 1 plus cosine alpha. Now I could factor out the 2. This is going to give me 2 times 1 plus cosine alpha all over sine alpha times 1 plus cosine alpha. And we can see it, right? This is multiplication, so this is just 1. And I'm left with 2 over sine alpha, which is 2 cosecant alpha. Okay, so there's our first example. Let's take a look at the next one. So cotangent squared of t minus 1, all divided by 1 plus cotangent squared t. That has to equal to 1 minus 2 sine squared t. All right, so I'm going to go ahead and change these into sines and cosines. There might be a identity out there that might simplify this, but I don't remember it because I only really remember the fundamental identities, the toolbox, that's it. So I'm going to say cosine squared t over sine squared t. That's this right here, cotangent squared t. And then minus 1, but the 1, I know I'm going to have to get a common denominator, so I'm already going to express this as sine squared t over sine squared t, and the reason I chose that is because I want to match it with this denominator, right? So that way I can put all this in over one denominator. Here I'm going to do the same thing, but let me go ahead and express this. This is cosine squared t over sine squared t. And then this one I'm going to make also sine squared t over sine squared t. Okay. So now I can write all of this over sine squared t, and I can write all of this over sine squared t. So I have cosine squared t minus sine squared t all over sine squared t. That's this. Now let me really exaggerate it. Then there's the very large fraction bar here. And now we have sine squared t minus cosine squared t all over sine squared t. Now, what I can't see is that these are going to end up canceling out, right? The sine squares. And then these, cosine squared minus sine squared, and then sine squared minus cosine squared, are pretty much the same, except you can factor out a negative sign. But where I'm headed is I'm going to want to have 1 minus sine squared t. So I'm going to have to look at how am I going to get that? Well, we'll see. So let's go ahead and flip and multiply, right? So we have cosine squared t minus sine squared t over sine squared t. This is this right here, the numerator. And now this is going to be flip and multiply, so I'm going to have times. Now this sine squared goes up here, sine squared t over sine squared t minus cosine squared t. And again, if this doesn't make sense, here's the aside. If I had, I don't know, 7 minus 5 over 4, and then 5 minus 7 over 4, that's the same thing as 7 minus 5 over 4 times 4 over 5 minus 7. Right, so this gets flipped and multiplied. All right, so now this cancels out, and I'm left with cosine squared t minus sine squared t all over. I'm going to go ahead and factor out a negative sign here, negative, and this is going to be cosine squared t minus sine squared t. Right. So I actually get negative 1, huh? Because this cancels out and I get negative 1. That is not what they get. I wonder if I wrote this one down wrong. Oh, I just saw something I did wrong. It's this kind of stuff that kills you. Take a look at this. Remember I said to you have to double, triple check that you really wrote everything down right? In the numerator I have a minus, in the denominator I have a plus. This should be a plus. Oh, it's funny but not too funny, right? So let's adjust that. So this was the numerator. This should be a plus here. And this should be a plus here. So my apologies. See, but I actually don't. I'm going to keep this video because you need to see that this is the kind of stuff that happens. It just does. So you learn another trick over here. Even though this doesn't apply to this problem anymore, it's still something that could have been used in another problem. So I think we're good up to now. I think I found the mistake. This plus is this plus is this plus is this plus. All right. So now let's carry this over. I have cosine squared t minus sine squared t, that's here, right? All over sine squared plus cosine squared, but we know that's what? That's just 1, all right? And we want to show that's 1 minus 2 sine squared t. All right, we're getting there, almost. So now since this is all sines, I want to change the cosine squared into 1 minus sine squared. So I'm going to do 1 minus sine squared t. And then just carry this, minus sine squared t. We don't need the divided by 1. So now you have 1 minus 2 sine squared t. So wow, what a difference, huh? And the other way that I'd solved it when I had the minus sign, right, it all became negative 1. But because of the error that I made in copying down just from here to here, this plus sign made all the difference. And sometimes you catch it, sometimes you don't. I mean, you know, you do the best you can. So obviously, when I got to negative 1, I went, uh-oh, something's wrong. All right, so anyway, because I had verified that I had written the original problem down correctly, so I knew I was right there. But this is it. These are the little techniques you have to check. Make sure you copy things down real well. This will be the last one for this video, so let's see here. Now, oh, neither side looks appetizing, but what the heck. I'll start with this side because it's still more complex. And at first look, I almost thought this is a trinomial because, you know, you've got a square and then a first power and then just a constant. But notice they're different functions. This is sine and this is cosine. So I think I want to head toward a trinomial because I think that's what's going to happen, but I need to change everything into one function since my fundamental identities are in terms of what I'm thinking of, right? This one here, I have to have you work with the squares. I'm going to have to change sine squared into 1 minus cosine squared. So I'm going to put 2, and notice I absolutely use parentheses so I don't forget all the distribution. This is 1 minus cosine squared x. So that's this right here. Now let me just continue writing. Plus 3 cosine x minus 3 all over sine squared. And I could write sine squared here, but I'm going to go ahead and go maybe 1 minus cosine squared because I see I'm headed toward a 1 plus cosine x, and I know that 1 plus cosine x times 1 minus cosine x gives me the 1 minus cosine squared. So I'm going to go ahead and go with 1 minus cosine squared x. I might be doing this prematurely, I'm not sure, but anyway. So let me go ahead and distribute here. I have 2 minus 2 cosine squared x plus 3 cosine x minus 3 all over 1 minus cosine squared x equals. Now let me combine some terms and things like that and try to clean this up a little. And here I do not get lazy because if I do, this is where I really make mistakes. It's usually in dropping a negative sign, as we saw. You can throw everything off, right? So let me get the leading term, negative 2 cosine squared x. The middle term, 3 cosine x, and then 2 minus 3 is minus 1, right? All over, let me go ahead and factor 1 plus cosine x, 1 minus cosine x. I'm hoping that when I factor this, I'll be able to cancel out one of these, which is probably going to be this one, right? Since we have the 1 plus cosine x here in the solution that we're trying to arrive at. Now, I don't like dealing with a negative sign in the numerator, so like in the leading term, so I'm going to factor it out, and I'm going to have 2 cosine squared x. So this is going to make this a negative, so that a negative times a negative is a positive. And that's just me. I like to factor when I have positive coefficients. It's just easier for me. And then here, minus times a plus 1. So here I have negative 2, I just double check, positive 3, and then negative 1. That's right. All over, sorry here, 1 plus cosine x, 1 minus cosine x. So again, I'm not being lazy at all. That's a really big deal. You have to like be willing to write everything down. So now let me kind of bring this down a little and see if we can follow this. This is going to be, let me check here. Yeah, okay, you can see it. All right, so now I carry this to, oops, sorry about the whole phone thing. All right, so negative, and here I'm going to factor this trinomial. So we're going to have 2 cosine x times cosine x, right? And then we need a 1, but a minus 3. So we're going to have a 1 and a 1, and they're probably going to be both negative. Let me double check. So I'd have 2 cosine squared x. And then, let me bring this down, make sure you could really see it. Need to cover everything. All right. Negative times a negative is positive, and then you have minus 1 minus 2 is your minus 3. So that looks good. All over 1 plus cosine x, 1 minus cosine x equals, and let me just kind of bring this down what we were trying to get to, 1 plus cosine x. Let me show you. All right, that's what we were headed toward. All right. Now let me move this back up. And let's see here. So now if I take this negative sign and bring it in here, it'll make this negative and that positive. So let me do that. 2 cosine x minus 1. I'm going to take this negative sign and distribute here. Okay? So I'm going to have 1 minus cosine x. And then here, 1 plus cosine x, 1 minus cosine x. Okay? And there we are, multiplied, so that cancels out. And I'm finally left with the 2 cosine x minus 1 over 1 plus cosine x. All right, that's it. Thanks so much for listening.